All right, hello everyone. My microphone should be working now. You guys have no idea how frustrating that was to realize I'd recorded those videos yesterday and that there was no audio, and then I was so tired, you guys. By the time I got them done, I just could not re-record them, so I really apologize for that. But I tested my audio out today, so we should be good. Okay, as you can see on the screen here, you are going to need one die today, and you are going to need 5 squares labeled with C, A, or T. So what I did, I just took Post-it notes and folded them into 4 to make little things. But if you've got really whatever, I mean, you could do scraps of paper too. It doesn't matter. But we're talking about probability today, so we're going to be picking different letters. So you need to have, so there's 5 of them, 5 like that. You need to have at least 1 C, 1 A, and 1 T. So the other 2, you can choose how you want to label them. I chose to do 2 C's. So however you want to do it, but go ahead and pause the video and gather those things and then restart when you are ready to continue. All right, so we're going to start with the die. It's a singular form of dice. If you have just one of them, it's called a die. And your book calls it a dot cube, probably because die is confusing. But anyway, it's called a die. So if we look on page 592, we can see a picture of a die. It has 6 faces, of course, you know that, and the dots are marked, and they point out to you on the page that 1 is opposite the 6, and 2 is opposite the 5, and then 3 is opposite the 4, okay? And what we could do is we can roll this dot cube, this die, and we can determine the probability of getting any number, okay? Now, with this die, we are equally likely to get a 1, 2, 3, 4, 5, or 6. Like they have an equal number, right? And so remember that we can write probabilities as fractions. So I could say that my chance of rolling a 1 is a 1 in 6 chance. My chance of rolling a 2 is a 1 in 6 chance. My chance of rolling a 3 is a 1 in 6 chance. My chance of rolling a 4 is a 1 in 6 chance, because there's 6 options, 4 is one of them. My chance of rolling a 5 is a 1 in 6 chance, and you guessed it, my chance of rolling a 6 is a 1 in 6 chance, okay? So each of these outcomes has a probability of 1/6. Now, interestingly, if I added them all together, I would remember that my denominator stays the same. And if I add up all those ones, there's 6 ones, I end up with 6 sixths, which is the same as 1 whole. Very interesting, right? So we could do a similar thing. So like if I asked you, if I roll this die, what is the probability that I will land on a number? So every side has a number, right? So your probability of rolling a number would be 6 out of 6. What would be your probability on this die of rolling a G? What would be your probability of rolling a G? Trick question, right? It would be a 0 in 6 probability because there are no G's on it, okay? All right, so I could ask a little bit more complicated probability question. I could ask you, what is the probability of rolling a 2, 4, or a 6? All right, so if I'm going to roll this die, I'm asking what is the probability that what I get is a 2, a 4, or a 6? To figure that out, what you do is you take the individual probabilities and you add them together. So what's the probability of rolling a 2? Remember, it's 1/6, right? What's the probability of rolling a 4? It's also 1/6. What's the probability of rolling a 6? It is indeed 1/6. And then we add them all together. The denominator stays 6, and then 1 plus 1 plus 1 is 3. So you have a 3/6 probability of rolling a 2, 4, or 6. And we could reduce 3/6. I could divide the top and the bottom both by 3, and I would end up with 1/2. So you have a 1/2 probability of rolling a 2, a 4, or a 6. So I want you to pause the video, and I want you to do numbers 1 and 2 at the bottom of page 592, and then I want you to restart the video to check your work. Did you pause the video? If you didn't pause the video, you need to pause the video. You can't just watch me do the work, okay? Got to be thinking on your own, so pause it now and do the work. All right. So probability of rolling a 1 or a 6. So again, my probability of rolling a 1 is 1 in 6. My probability of rolling a 6 is 1 in 6. So you should have added those together and got 2/6, which we would simplify down, divide them both by 2. And so you should have gotten 1/3. I would also accept 2/6, but 1/3, sorry, tilted my paper. 1/3 is the best answer here. For number 2, what's the probability that the die is going to show us a number that's less than 5? How did you figure that out? Well, you should have thought to yourself which numbers on this die are less than 5. That means it could have been a 1, a 2, a 3, or a 4. So their probability of rolling a 1 is 1/6. Probability of rolling a 2 is 1/6. Probability of rolling a 3 is 1/6. Are you getting tired of hearing me say 1/6? The probability of rolling a 4 is 1/6. It's actually quite difficult to say over and over again. It's like a tongue twister. So denominator stays the same. Add together the numerator. I get 4/6, which is fine, but even better, best is if we simplify it down, reduce it to 2/3. All right, so if we look on the next page, okay, if you take this dot cube and you roll it a bunch of times, you can actually predict how likely something is to occur. And so we're just going to read through the top of page 593 together. So I'm going to read and you can listen. Feel free to read out loud with me if you'd like to. If we roll our dot cube repeatedly, we can predict how many times certain events will occur. Our guess is based on the part of a meaning of a fraction. Suppose we rolled our dot cube 24 times. Since all the outcomes have a probability of 1/6, we predict that we would roll the number 2, or any other number, 1/6 of the 24 times. So we would divide 24 divided by 6. Okay. So if you had to, if you know the number, the total number, and they're all equally likely, then you can take the number of rolls and divide it by your options. So there's 24 rolls divided by 6 options on the cube means you're likely to get a 2 4 times. So next paragraph. Because 3 faces show even numbers, we would predict that we would roll an even number 3 times 4 times, or 12 times. But these are only guesses, okay? The actual number of times that an event will occur cannot be predicted with certainty. So let's think about question 3 here. We're making a prediction here. If a standard die, a dot cube, is rolled 60 times, how many times would you predict that the upturned face will be 1? What do you think? So we're rolling it 60 times. And there is a 1 here. There are 6 equal options that we roll. So we should do that total number of rolls divided by the number of possibilities. And we would predict that you would roll a 1 10 times. That's a prediction. It's not a certainty. It's a prediction. Okay? All right. So how about for question 4? Same idea. What if we roll this die 60 times? How many times would we predict that the upturned face would be either a 1 or a 6? Well, now what we're thinking about is chances of rolling a 1, there's there's 6 equal chances, but then there's also like another, no, I'm explaining that wrong, sorry. Chances of rolling a 1 are probably about 10 times. Chances of rolling a 6 would be another 10 times. It's like 10 times for the 1 and 10 times for the 6. And so our prediction is that we would get it about 20 times. Okay, so next video, you're going to be doing the activity. The videos are going to be a little longer today, but you don't have an assignment, so woohoo for that. All right, so go ahead and move on to the next video where we will do the activity.